and welcome to the new product update of TI's latest Wi-Fi 6 companion ICs. My name is Vihang Parmar, and I'm a product marketing engineer responsible for this portfolio. I also have my colleague Andres Blanco, who manages the software applications for these devices. For today's agenda, we will first discuss common design challenges for Wi-Fi and how the TI Wi-Fi portfolio is making it easier to enable more efficient wireless connectivity in IoT applications. I will also provide an overview of the latest CC3300 and CC3301 devices from our Wi-Fi 6 family, and an example application of this companion IC. Then Andreas will show us how this IC can be easily attached to a Linux or RTOS-based system. Lastly, we'll show you the design resources to get started on your development. Throughout this webinar, please feel free to send us your questions in the chat, and we'll address them as we go. Today, we are experiencing an era of hyperconnectivity where more and more smart devices are connected to the internet to provide ever-increasing number of data points that help us make better, more informed decisions. They are enabling us to personalize experiences, streamline operations, and predict future trends with greater accuracy than ever before. As more of these smart devices or edge nodes of the network are connected to the internet, there is a growing need for the solutions enabling this connectivity to provide robust performance in any environment. As the technology landscape is rapidly evolving, there is an urgent need for these connectivity solutions to future-proof the design with latest connectivity standards. Standards that can ensure interoperability and security while also providing the flexibility to scale across various platforms. TI's connectivity portfolio is addressing these needs by offering affordable and reliable wireless and wired technologies. With our broad portfolio of solutions featuring the latest connectivity standards and comprehensive features, you can connect more devices to the internet and drive innovation for your products. Talking about Wi-Fi specifically, designing Wi-Fi in high-density environments presents unique challenges. Striking a balance between consistent RF performance and a reliable connection can be tricky, especially in spaces crowded with devices. Adding cost effectiveness into the equation only complicates matter further. Additionally, security is a major concern as number of connected devices increases, so do potential entry points for cyber threats. We're also contending with complex certification processes and need for flexible design that caters to the variety of architectures. Lastly, the issue of coexistence with other wireless technologies come into play. We must ensure that our Wi-Fi solutions don't interfere with other wireless signals. So driven by these challenges, we continue to innovate, striving to deliver superior Wi-Fi solutions for these challenging environments. Our new SimpleLink Wi-Fi family of devices help overcome these challenges by providing robust Wi-Fi performance at an affordable price. Starting at a competitive price point of $1.60 for 1 KU volumes, these devices help enable cost-effective implementation. These devices support the latest Wi-Fi 6 and Bluetooth Low Energy 5.3 standards to help future-proof your designs, and they can also easily attach to a processor or MCU in your system to provide the scalability across various platforms. So let's take a deeper look at these new devices. So on the left, you see the block diagram of our newly released CC3301 part. These parts are currently sampling, and you see two variants in this family, CC3300, which offers the entry-level Wi-Fi 6, and we also have CC3301 that adds Wi-Fi 6 and Bluetooth Low Energy 5.3 all in the single device. Now, looking at the device block diagram, you'll notice that we have the offering for CC3301 that includes the Wi-Fi and BLE built into the same radio, and it has a single antenna output. This means not only you get a coexistence built into the device between Wi-Fi and BLE protocols, you also have a single antenna output that only requires one 2.4 gigahertz antenna. So while having a single stream and reducing your overall BOM cost, you get the two protocols in the same device. Moving over to the left, you'll see some of the main interfaces this device can use to connect to an external processor or MCU are SDIO or SDI interface. We also have an optional UART interface for Bluetooth over HCI. Additionally, we also have a coexistence interface built into the device that can help connect to other 2.4 gigahertz devices that may be running other protocols like Zigbee, Thread, etc. These devices offer the network efficiency benefits of Wi-Fi 6 with features like OFDMA and BSS coloring. And additionally, they also support wide temperature range from minus 40 degrees Celsius to 105 C. All these devices in our portfolio, they're tested with hundreds of access points that are common in the market. So that also helps you ensure that when you use this device in your product, they can work seamlessly with common access points out there and have a best possible interoperability. We're also trying to solve the security challenge by integrating some of the built-in functionality into this device. So we have support for latest WPA3 standard for this device, and there's also a firmware authentication built into the device that you can enable to make sure no one can load an older firmware to the device. So we're keeping security in focus for this device. And lastly, this device is designed to be flexible. So like I had mentioned earlier, you can connect it to like a Cortex-A class processor that might be running Linux, or you can connect it to microcontrollers that might be running real-time operating system. With that in mind, I'd like to talk to you about a few of the applications that this device can go in. Because of its cost-effective design and secure, reliable performance, this device can be used in a variety of applications ranging from smart homes, building automation, like the security for building security or the HVAC and fire safety systems, to smart grid applications where devices might be deployed inside and outside home, whether that's electricity meters, solar renewable inverters and battery storage, or EV chargers. Because of the cost-effective design, this device can also meet your price and performance needs for cost-sensitive applications like appliances and personal electronics like printers and electronic point of sale, etc. So I'd like to dive a bit deeper into one specific use case, and we can take a look at how these CC33 family of devices can add value to your application. So here's an example of a smart energy management deployment. You'll see there are several applications that are generally Wi-Fi enabled in this scenario. From the left, we have the HVAC and heat pump system that could be connected to Wi-Fi. And looking more outside the home, we also have some of the smart grid applications, meter, energy gateways, energy hubs, the battery storage solutions, and EV chargers, and inverters, microinverter or string inverter for the solar energy. So as these devices can be deployed inside or outside the house, there is generally a huge consideration on the outdoor thermal performance of the device. So we are designing these parts with with this requirement in mind. And as the result, our CC33 family of devices support operating temperature up to 105 C. So you can ensure that your device has consistent performance across the wide range. Additionally, we also have robust RF performance, ensuring that whether deployed inside or outside the house, you get the best possible performance on the Wi-Fi network. Now, having an affordable and reliable device like this has several benefits at a high level. For example, this allows you to put more Wi-Fi connectivity at an affordable price in more applications, and that will ultimately help us enable, in this particular scenario, grid companies can use the data gathered by these devices and have a smarter load distribution. So this is one example. Of course, devices deployed in the house, in the office buildings. There are also similar benefits that come from the device's performance and overall Wi-Fi 6 improvements in the standard. So with that, I will hand over the presentation to my colleague, Andreas, who will walk us through how these devices can easily connect to any host.
Yeah, hello everyone. So as Vihan has mentioned, one of the key principles that we followed when designing this new device is the ability to have it be flexible. And by that, we mean, having the capability of being able to add it to an existing solution of yours that may already have a host processor of your choosing in it already, or if you're designing a brand new system, not be tied to a specific host. And the way we achieve this is by allowing you to connect it to either an MPU or an MCU. But we go a bit further than that. And let's say that your system requires you to have a Linux system on an MPU type host. Our plan is to have drivers being upstreamed, and the drivers are portable in a way that the main thing you need to do is change the device tree settings on your system and apply the correct pin configuration, and you should be good to go. Today, for example, we have it running on the AM335 devices, but also the brand new AM62 devices that TI recently released and announced. But we won't stop there. We also have other systems that we can work with. On the right side here, we show you how we're not limited to only running with Linux. So let's say that you have a more memory-constrained RTOS type system, and you have an MCU. If your MCU has enough memory, and by enough memory we mean between 500K and 1 meg, should be more than enough. You can connect the same transceiver, and the main difference is instead of leveraging the Linux networking stack, you will need a networking stack. And our device and our software that we provide allows you with a good and portable abstraction layer in order to use whatever networking stack your system needs. We do offer ready-to-go examples with the CC26 52 family of devices and the AM24. But there are more examples to come with other family of devices. It's not going to be limited to only TI hosts, and also we will focus on offering multiple networking stack solutions, so that you are not limited by the software or the hardware on the host side, and you can use our devices with any platform that your system needs. With that, I leave it back to Vihan.
Hi all. So this device, we have the software offerings for both Linux and RTOS ecosystem, and we also have the evaluation module that can help you kickstart your development easily. So we have the samples of the devices available, and the board you see on the screen here, that is our BPCC3301, and it is available on TIA.com as well as in the additional resources of this webinar. So feel free to order that or reach out to your local TI contacts to access this hardware tool. And similarly, the software SDKs are also available on the CC3300 and CC3301 product pages, where you can request the access to download them. We have the support for this device in the TI Developer Zone and also on our E2E support forums. Here are some of the resources that you can leverage. There are direct links to the product pages and also a tech article explaining in a bit more detail which Wi-Fi 6 features we are enabling in this device to help the IoT use case and keeping your solution very cost effective. The last two, we have the software and the booster pack links that you can download from here as well. With that, I would like to thank you all for joining today's webinar. And we do have some questions in the chat that we can address real quick. So there was one question, if WPA2 Enterprise is supported. Yes, so this device has WPA3 support, but it is backward compatible with WPA2. And second question was, is there a plan to integrate a host network processor like our CC32XX family or 5 GHz Wi-Fi? So I may not be able to share full details of our roadmap, but TI makes Wi-Fi solutions in different architectures with varying level of software integration for different applications. So I would highly recommend, if you're interested in in our upcoming devices, please feel free to reach out to your local TI sales rep or FAE, and we can discuss our roadmap in much greater detail to suit your needs. And was there another question about, does the BLE 5.3 support CTE for angle of arrival locationing? Andres, could you quickly answer that?
Yeah, definitely. As of now, we have the basic 5.3 functionality from BLE. But the good news is that we are leveraging the same BLE stack as what the CC26XX family of devices use, and they do offer this functionality. And that's something that we're looking into. At the moment, we're focusing on enabling all of the 5.3 functionality and having that ready to go.
There was another question, how about the module solution availability? So really good question. Right now, we have several third-party module vendors that are using this device, and they are sampling the modules based on this solution. So if you're looking for a module for either faster development cycle, for time to market, or just offloading the certification effort, we do have solutions based on this device, and you can find more information on the product page regarding this too. With that, I think that was all the questions. So thank you again very much, and I'll I'll hand over to Kelly to conclude.
All right, thank you. And thank you everyone for joining today's MPU webinar. Next week's MPU, we will have automotive product marketing engineer George Lackas here to present improved traction inverter system efficiency at a lower cost with real-time variable gate drive strength. Be sure to register for this upcoming session by visiting ti.com/MPU and click on the register now link. Thanks again for being here, and we look forward to seeing you again next week.